Hello and welcome to this video. In this video we will do a couple of examples of nodal analysis when our circuit contains an independent voltage source. Voltage sources complicate nodal analysis a little bit. It's actually not that bad, and in the case that we have here on the screen, for example, the voltage source can actually simplify the computation, but it does mean that our steps that we have developed to do nodal analysis need to be modified a little bit, and we'll show what that modification is as we go through this example. Okay, so step one in doing nodal analysis is to choose a reference node, and again I will choose this node at the bottom. For some reason I can't really choose any other node. I've been conditioned to choose this one. The next thing we'll do is mark our node voltages. So we have a node here, which we'll call V1. A node here, and we'll label the voltage here V2. And finally, a node here, which we'll label V3. Okay, so far so good. Well, the next thing we can do is start writing down equations at each node. Then we just have to solve the equations and we're done. So what can we say about node 1? Well, you'll notice that I have a 5-volt source between node 1 and my reference node. So between here and here, I have 5 volts. So that tells me that V1 is equal to 5 volts. Isn't that handy? So if you have a independent voltage source between your reference node and another node, it actually simplifies the computation somewhat because it tells you exactly what that node voltage is. So in order to find V2 and V3, I just have to continue with my nodal analysis. V2 looks like the nodes in the introductory video, so I can just write down the equation for from node 2. I'll have minus V1 excuse me, 1 over 1 k ohm plus V2 times 1 over 1 k ohm plus 1 over 2 k ohms plus 1 over 3 k ohms minus V3 times 1 over 3 k ohms is equal to 0. Okay, so this is a perfectly good equation. Now, if I wanted to, I could actually take this 5 volts, the value that I know, and substitute it in for V1. I'm actually not going to do that because it's not going to simplify automatically solving the system of equations much, and it would involve a little extra effort on my part, so I'm just not going to do it. So now let's look at node 3. And at node 3, we have minus V2 times 1 over 3 k ohms plus V3 1 over 3 k ohms plus 1 over 4 k ohms, and this is equal to 0. So there we have it. We've gotten 3 equations and 3 unknowns. The thing that made this different from the previous, from the introductory example, is that the 5-volt source between node 1 and our reference node actually made the equation at node 1 very simple. It's just V1 is equal to 5 volts. So now I'll use my current favorite approach to solving this system of simultaneous equations, which is Wolfram alpha. And it's kind of fun because you can change the background, which I'm doing every video because it just looks so nice. Okay, so we have V1 is equal to 5. That's our first equation. If we go back now and look at our second equation, we'll have minus V1 over 1 k ohm plus V2 1 over all these guys minus V3 1 over 3 k ohm. So let's see if we can get this in correctly. We have minus V1 times 1 over 1,000 plus V2 times 1 over 1,000. Wow, I'm not very good at typing 1,000 today. Okay. Plus 1 over 2,000 plus 1 over 3,000 minus V3 times 1 over 3,000, and this is equal to 0. And then we go back to look at our diagram. Our last equation, it's going to be minus V2 times 1 over 3k ohms plus V3 times these guys is equal to 0. So we have minus V3 times 1 over 3,000. Whoops, got that wrong. Should be minus V2 times 1 over 3,000 plus V3 1 over 3,000 plus 1 over 4,000 is equal to 0. And now I should just be able to hit return, and Wolfram Alpha computes my voltages for me. I go down here, put them in approximate form, and we see then that V1 is 5 volts, which we would expect. V2 is 3.04 volts, and V3 is 1.74 volts. So we go back to our circuit diagram, and we can write in these voltages. 5 volts, 3.04 volts, and 1.74 volts. And there you have it. Solving a circuit using nodal analysis when you've got a voltage source that is connected between a node and your reference node is really pretty easy. And I think with that we'll end this example, and in the next video we'll have an example where you've got multiple voltage sources, one of which is not connected to the reference node. So that'll give you something to really look forward to.